organizations that people can, or the students can take advantage of, and these are some great opportunities for students to do some learning outside of the classroom. And we actually are going to have current Cal Poly students talk about some of those clubs later on. All right. All right, so just kind of a little snapshot or two of what some of our students are doing. So our students, they get a chance to travel around the country for their organization. So the AIAA is it's the National Aerospace organization that has a student chapter at Cal Poly. And so they traveled back east a couple years ago, and so we have that. They take field trips all different locations. So this one set of students were doing some research with Tesla, and so they took a trip up to the Tesla facilities and got a tour there, and was able to do a presentation there. We have an amateur rocketry club called CPSS, and CPSS, they do their launches out in the desert with other amateur rocketry organizations. And so this is them setting up one of their larger launches. We also have some students that work on autonomous flight vehicles, and so that is down here in the bottom left. That's a student who's working on a UAV. Some students here, they've been working with our faculty member here, Dr. Iskold, working on a glider, and so they've been working on fabrication as well as the design for this glider. And then finally, over here on the bottom right, we actually have a class that students can take as an elective. It's focused on test flight, and so we take students up in our aircraft to do some test measurements as part of the lab experience for that class.
David, there was a question. I don't know if you want to address that now.
Yeah, so I see there's a question about research opportunities for supersonic flight. So we have a supersonic wind tunnel that we can do some testing in. So there's the capability of doing flow visualization as well as some other experimental activities there. We also have a lot of computational resources available for students to look at supersonics and hypersonics. And so right now we actually have a few graduate students that are working on doing some computer simulations of hypersonic vehicles and comparing that to existing test data. So there are definitely research opportunities that undergraduates as well as graduates can take advantage of. So, all right, thanks. All right, so we also host a lot of events throughout the year to help keep the students engaged. The first class that you would take that's an aero class, it would be in the fall, and that class is it's called Aero 121, and it's basically an introduction to aerospace engineering, and it's split up into two parts. The first part is focused on students breaking up into teams, and the team objective is to assemble a small rocket. And the rocket has an egg as a payload, and there's a friendly competition to determine who can launch the egg the highest and have it land and not break without a parachute. So there's a lot of interesting engineering problems associated with this, as well as getting students to learn how to work in a group and navigate that team dynamic. So we actually do the rocket competition on Parents Weekend. So it's a pretty fun event, and it's like I said, it's a friendly competition. It's great to see how everyone does, and it's great to see the ingenuity that students already have. At the end of the senior year, we have what we call the design symposium, where students in their senior year, they've been working an entire year on either an aircraft or a spacecraft design of some sort. And so they get to present their designs to industry representatives that come on campus, as well as faculty and staff that are there to see the presentations. That class, as well as doing the design symposium at the end of the year, they actually will take trips throughout the year to industries locations and do practice presentations and for those organizations, and get feedback from those organizations' engineers. So it's a great opportunity for students to get some more experience. It's another opportunity for students to get in front of real engineers and get feedback from those engineers. All right. On top of that, we do host a Cubesat Workshop every year that brings in Cubesat experts from around the country, and that's a great opportunity to see what's the latest thing that's going on in Cubesat. And on top of that, there are various club events that we help host and sponsor, as well as a couple of years ago we had a DBF, a design build fly competition that we hosted here. All right, and a quick check. Can everyone see this slide here about student organizations?
If they can't, what should they hit?
Wow, that is a great question.
I know, I'm looking at.
If you can't see it, because apparently some people are able to see it, that is a.
Looks like most people can.
Yeah, it's like that's a Zoom question that I just don't. My 2 weeks of Zoom hasn't taught me enough on how to troubleshoot, unfortunately.
John or Justin, do you know? No. Okay. I won't put you on the spot.
So someone says top right corner, swap with video.
Swap.
Icon with picture within picture.
Oh, swap shared screen with video. Yeah. Okay.
Okay.
Thank you, Connor.
All right. Okay, so some of the student organizations that we have, the Aircraft Design and Construction Club, they usually have a project that goes throughout the year, where they look at designing and building some kind of smaller aircraft, so that they can learn some of the practical implications of what it takes to actually design a vehicle that needs to fly, as opposed to just doing the analysis work for it. So usually the wingspans for these things are less than probably 10 feet. So they're smaller, and usually they're RC aircraft. And it's a great experience for students to see the practical side of aerospace engineering. AIAA, I already mentioned that. It's a student organization as well as a professional organization that most aerospace engineers are members of, or at least know of. ACAFLEEG, they are a club that we'll be presenting later, and it's another flight club, and this is more geared towards, I believe, towards sailplanes. CP Intercept, that club is working on rebuilding a Boeing satellite that was never used and is never launched, and it was donated to Cal Poly by Boeing. So the satellite is about 3 stories tall, maybe 2 to 3 stories tall. So it's one of their large satellites that they had built but then never needed to launch. So we have a lot of the schematics and a lot of the design information for it, and so students get to fabricate as well as assemble the different components for it. CPSS, that's the Amateur Rocketry Club that does a lot of really fun stuff with rockets and in fabrication as well as design. Cubesat, we've talked a bit about already. So DBF, that's the design, build, fly. They participate in the competition every year that AIAA puts out, where they have a task and they have to design, build, and fly some kind of vehicle to accomplish that task. Proof we talked about, Stampy. So that's a club that's focused on materials, and there's a lot of aerospace specific materials that we have to know a lot about, especially composites and high strength metals. And then Sigma Gamma Tau, that is the Aerospace Engineering Honor Society, and they do some volunteer work and they do some help with tutoring as well. All right. So just to give you a bit of an idea of what our degree program is here at Cal Poly for the undergraduates. So it's a 4-year program, and it's 4 years of a lot of work. It's a lot. We sprinkle in aerospace classes throughout the 4 years, but you also need to know some math and science and some fundamental engineering classes before you get to our aerospace specific engineering classes. So the first 2 years are really kind of building up your foundational knowledge in engineering, and then you start taking a lot more aerospace courses by the end of your second year, and that's where you start taking some fluids classes, as well as a class on programming and how to solve engineering problems using programming language. Then your junior year, you're going to decide whether you want to focus on aircraft or spacecraft, and depending on that, we have a different flow chart. So this flow chart I'm showing right now is actually for the aeronautics concentration. For that, you're going to take classes like aerodynamics, you're going to take aircraft controls, you'll take a class on aircraft propulsion systems, and then you'll finish off with an aircraft design class. So the question is, how would AP credits weigh into the courses that students have to take? So usually what happens with the AP credits is students don't have as heavy a load the first 2 years, because they can maybe get out of some of the calculus or some of the physics. So that allows students to spread out some of the other fundamental classes that they'll need by the end of the sophomore year. Allows the students to spread that out and be a little more flexible with their course selections. And our undergraduate advisor, Dr. Abercrombie, she's very well versed on how to adjust the flow chart for students that come in with a variety of AP credits. So she will set up meetings with students who have questions about those kinds of things, and help them set up their individual flow chart in a new system that Cal Poly's put together that helps students track classes and when they need to take them and when they're going to be available. All right. So this next slide here, that's the astronautics concentration. So the astronautics concentration is focusing on all things that are basically not in atmosphere. So we don't this doesn't focus so much about launch vehicles, because Launch vehicles kind of split the difference between the aircraft and spacecraft side. There's some, there's a class in the senior year on propulsion systems, and the launch vehicle propulsion topics are covered there. But there's a lot of unique aspects to to space itself that we get our students to have a really good understanding of. So they take a class on orbital mechanics and a class on spacecraft controls, and then we also have a spacecraft attitude dynamics and controls class, and then we talked about the space environments class. So, and then they finish off with a year of the spacecraft design as well. All right. So our labs, we have the majority of our labs are located in 3 different buildings on campus that are pretty closely. They're really close to each other. They're on the south side of campus. So going between the 3 buildings is not very long of a hike. There is a 4th building. We call it the Aero Hangar, that some clubs are in, and some other activities happen there once in a while. But for the majority of what we do on the lab side, then we have three different buildings. And each of these buildings, they house both research activities like Cubesat, and is in this first building here, 192. So Cubesat has a pretty big footprint on the first floor of 192, and that's where they do a lot of their design and fabrication work. And then we also have our design labs that are up here on the 3rd floor of 192 as well. And then we also have a computer lab that is in this building as well. Building 41, this is where a lot of the faculty offices are, along this hallway here. And then we also have our wind tunnel is located right here. Our space environments lab is right here. We also have our structures lab right here, and then we have a propulsion lab facility that's set off from the others. It's right here. And then in what's called the Atl Lab building, we actually have, this is the one that doesn't actually have any educational activities going on in terms of classrooms. This is a space dedicated for undergraduate and graduate research activities. So we have the Autonomous Flight Lab that's over here. Cubesat takes up several of the rooms over here, and then we have a computational fluid dynamics lab facility right there, and then we also have space over here for some other research activities like Cubesat and sorry, not Cubesat, sorry, but for Proof. Let's see here. So there was a question that came up, are there already advisors for us to talk to about our future classes and paths? So I would say probably at this point, the first place I would go to talk about future classes would be Engineering Advising Center. They are pretty well versed on what incoming students need to take and some of the unique features that certain students might have in terms of their curricular needs. So I would ask them, and if you don't hear anything from them, then that solves your problem, and they'll know who to direct you to, whether that might be the registrar or what would it be to the department in particular. So that's who I would start off with. Engineering advising is a great resource that the students take a lot of advantage of. The good question about where can we find the flowcharts. So the flowcharts, oh, and Edward, thank you for putting that link up. I actually find it by going to our catalog, and then from the catalog I go to the degree programs. But apparently there's an actual website, flowcharts.catalog.edu. All right. All right. So with all of that being said, now we are going to hand this off to the different clubs. So the first one is Aircraft Design and Construction Club, and John's going to talk from them. And John, don't worry about correcting me if I said anything wrong about your club. All right, so take it away, John.
All right. Hi, everyone. Can everybody hear me okay? I hope. I actually brought a few other of the ADCC officers with me. My name is John, as you heard, and I'm the president of ADCC. Also with me is Matt and Malin. Matt and Malin, you want to say hi?
Yeah, I'm Matt, and I'm the treasurer of ADCC.
Hi, Matt.
Cool, and I'm Malin. I'm the safety officer of ADCC.
Hey, Malin.
So yeah, they're two of the guys I'm working with regularly, and ADCC stands for Aircraft Design and Construction Club, and our focus is giving students the opportunity to use engineering principles to design and manufacture small aircraft. We don't yet go to competitions, and we usually pick our projects at the beginning of the year based on member interest. So a typical year for us consists of voting on projects to do and designing them in the fall, manufacturing in the winter, and then flight attempts in the spring. To fuel our mission to provide engineering experience to all of our club members, we usually run multiple projects throughout the quarter. And so here's a look at our main 4 for this year. First is Intro to Fixed Wing and Quad, which I lead for the most part. And that is basically for a lot of new members, freshmen, or incoming students who don't entirely know a lot about design and manufacturing techniques. So then we teach them the basics of those, let them build their own little quadcopter drones or RC planes. As you can see on the slide, that picture is from an RC plane that they taught me how to make my freshman year at Cal Poly. And we were pretty far along with most of those for this year, and we're hoping to get them flying in the spring, but we'll probably then end up continuing those over to next year. Now I'm going to hand it off to Matt to talk about a couple more of our projects.
Yeah, so we're also building we're in the manufacturing process of a remote controlled aircraft, and we're aiming to fly that at speeds over 200 miles an hour. And we're mostly making that out of carbon fiber and other composites. So we're working on the manufacturing for that right now. And we're also working on a pseudo satellite, which is a solar powered drone with about a 16-foot wingspan. And we're aiming to fly that for 24 hours continuously and almost autonomously. And we built a prototype for that. And right now we're working on the final aircraft. I'm going to hand that off to Malin for our final look.
Yeah, thanks, Matt. While most of our other projects are solely engineering based, we also have drone racing, and we're starting that up. We started it up this past year, and we're working to get through a few more regulations, but this program is going to hopefully merge engineering construction concepts and flight skill in a competitive environment, which is going to be really cool and new to ADCC. With 2 different divisions, we'll have drone racing and flying wing racing. Our club members can practice and improve on both their construction techniques and flight skill, and in the future compete. And so by implementing engineering principles and model aircraft construction techniques on all of these projects, we can work with our members to bring all of these concepts to fruition in the real world, which is really cool. So I'll hand it back off to John for closing.
All right. Thanks, guys, for listening to us today. Again, you can find us on the Cal Poly Aero Department website under clubs, or you can email us at calpolyadcc@gmail.com for questions, regular club activity updates, and project member inquiries. Thanks.
All right, thanks. Thanks, you guys. Does anyone have any questions for the ADCC club members? Because I have a question that maybe they can answer. It's because someone asked on this, does anyone know where the engineering dorms will be housed? So my understanding of the freshman year is that students are not separated out by majors or even by college. So the dorms are basically mixed with everybody. Is that right?
That is correct. You can ask to be housed with certain people of like similar interests, and they've got those interests on some kind of housing application that you have usually. But my freshman year was living up in the Cerro Vista apartments, which were super nice, with a bunch of honors kids. One of them was bio, one of them was econ, and I think another one of them was business. So it's really a mix if you want it to be.
Yeah, and I personally would like that, just so that you're not in such an insular environment for your entire time here, and you get exposed to all the different people on campus. So guys, there was another question that came in. How much composite work does ADCC generally do?
Probably specific to which projects we're working on. Right now, we're working on a lot of composites, just by nature of our low drag RC and our pseudo satellite. And so right now and in the immediate future, and probably for next year, we're going to work on the composites. But it really just depends on which projects we're taking on at the moment.
And do you all use our autoclave for the fabrication?
We do use a lot of the Aero and IME machine shops. It really kind of depends on what project it is, but we also have a lot of our own resources that we've invested in over the years located in our club space.
Okay. All right.
Go ahead, David. There was a few other questions.
Yeah. So are freshmen able to join this club?
And non-Aeros.
Yeah. We like to provide these construction hands-on project experience to students of all skill levels across all majors. And we find that while we do have a good majority of our club members as aerospace students, we have different forms of engineering majors. I think we might even have one or two that aren't even in engineering. And they're there because they love the idea of making their own aircraft and learning about that, or being part of something that flies and is tangible, which is really cool. So yes.
Yeah, and I also think a lot of the clubs they'll take students from any program, and it's really great to see the collaboration that goes on there and the unique contributions the students can provide. So some groups will actually have people from marketing or graphics design, and they will help kind of do a lot of the marketing materials as well as some of the engineering work. So it's great to see everyone working together in that bigger goal.
Yeah.
What's the time commitment for this club? Someone wants to know.
It can be anywhere from 1 hour to 2 hour to, I'm in the club space myself, or this last winter quarter, I was 10 hours a week, I think. And that's just because we're in there a lot of the time as officers trying to provide as much time for students to work on their projects as they want. So people doing intro to fixed wing or intro to quad, or even working on a lot of the other projects can come in their free time with an officer and work on whatever they want to get done. So yeah, kind of varies depending on what you want.
Nice.
All right. So thank you again, ADCC. Let's go to the next club. All right. So Design, Build, Fly, DBF. And this is Austin Berg who's going to talk with them. Go ahead, Austin.
Hey, everybody. Yeah, thanks, Dr. Marshall. I appreciate it. Hope everybody's doing okay. And yeah, I'm Austin, and I'm here to represent Design, Build, Fly. We're a pretty cool club, and I'm just speaking as president. I'm a junior this year, so I've been in this club for 3 years. I've always enjoyed my time in Design, Build, Fly. So what we do is we're a team. So obviously Cal Poly's team, there's about 19 students of us, and each year we compete in the AIAA International Design, Build, Fly competition. And what this competition is it's basically they put out a set of rules and scoring parameters for teams to design and build and fly RC aircraft around. So we'll usually get the rules and then build a bunch of prototypes, do a lot of testing, and then compete in April against more than 130 other teams. So yeah, it's a small scale plane, sort of like ADCC does, but it's super mission focused. And we also complete a design report and submit it along with the proposal. So you also get a lot of experience in doing that sort of thing. Usually just from questions that the ADCC got, we can spend, if you're an officer, it's expected that you spend about 6 hours a week. But of course, everybody's welcome to do more. That usually people do what they can, and a lot of some like key members, when we're really working really hard, we can spend up to like 10 to 12 hours, but it's all really enjoyable, and we really enjoy working as a team. So the last thing I'll say is you also get a lot of leadership experience, especially if you apply yourself and demonstrate that you're willing to work with others. Then you can not only get a lot of technical experience about doing this sort of stuff, but you can also get leadership experience.
Thanks, Austin. Are there any questions for Austin? I have one for you. What kind of missions does the design build fly usually have to accomplish?
Absolutely, great question. So this year we had to design a banner towing bush plane. So if you look at this technical drawing, you can see a couple, kind of weird mechanisms. What these work together in unison to do is hold a large banner and then tow it as it was flying around. So another thing I had to do was hold these little miniature passengers, which I usually have sitting around, but I guess not today. They must have moved. So I did that too. And then the short takeoff. So you can see this picture. It's pretty much vertical off takeoff because we had so much elevator control. I think we over rotated a little bit, but that was from this year. And last year, what our mission was dropping bombs. Okay, so dropping these little Nerf footballs. It was a military. It basically simulated aircraft carrier operations, sort of like a P-38 type of aircraft, but it could drop bombs. I know these Nerf footballs, and that was the main thing. Took off from a ramp. It was a really cool airplane that year. The year before that, we had designed it's a really small scale airplane. Basically, how small and how light can you make it? But yeah, really cool stuff every single year.
And then another question that came in: how can freshmen get involved in DBF?
Yeah, sure thing. So usually, as a freshman, what you can expect in the club is you do a lot of the building, because you don't have as much aerospace engineering experience, like actual design stuff, like sizing the airplane and the technical stuff. But if you look at the drawing or at the plane, you can see that we built it out of balsa wood, and a microlite is the thin, those are the main things. And building those is actually pretty cool. And these are skills that you can apply, when you head back home. It's not too expensive to, manufacture, build the airframe at least. So that's what you can expect to do, is learn these techniques and then apply them on real aircraft. And then I'll tell you what, it's awesome when you see it actually flying. It's one of the best things ever.
All right, great. Thanks, Austin.
Yeah, absolutely. Thank you.
Yep. All right, so the next group is Proof. And for Proof, it's Joseph Hammond. Take it away, Joseph.
Kristen is also here, but I'm Joey. I'm one of two project managers on electric endurance car. That's the car on the top right. And then Kristen's also here. She's one of the two project managers on solar car. It's the car below. So we are Proof. We're an organization whose goal is to design and build alternative energy record-breaking vehicles. So the two projects there, electric endurance car, the goal there is to go over 1,000 miles on one battery charge. And then the solar car was to break a land speed record with purely solar panels, like no batteries or anything else. So Prove and another club on campus, EWB, are kind of why I decided to come to Cal Poly. They were two like really interesting clubs, so I'm really excited to be talking to you guys today about all this. We differ from a lot of other organizations on campus because we're a fairly young club and we have a lot longer term projects. We're also probably the least aerospace club that you're probably going to see today. But yeah, our projects have a lot longer life cycles. We go through the concept of wanting a car, figuring out, or any vehicle, figuring out what that means, going through the systems engineering, the conceptual design, designing it, actually manufacturing it, testing it. And yeah, a lot of people wear a lot of different hats on the club. I've had the chance to do design work, analysis work, manufacturing work. I even spent some time to like optimize the lab, planned out recruitment, did partnership work, did program management on like, and then the design work is on a bunch of different systems. So in Improve, like people really get the chance to do all kinds of different things. Yeah, since a lot of you guys are asking about freshman involvement, we don't really care how knowledgeable you guys are on things, just that you guys have the right approach and that you guys are interested in things, like learning new things and tackling all kinds of different challenges. So the way that we take on new members, we don't care what skill level or class they are. We give all the recruits kind of these projects that they can work on, things about the car that we don't know yet, things that we need to look further into, just challenges that we are actually struggling with. They're just kind of on the back burner because they're not the forefront challenges. You work on that with the team for a little bit. There's an interview process, and then if you get on the team, you pick up that project right where you left it off, and we can help you design further. Time commitment, since you guys were asking about that too. I probably spend 20, 25 hours a week on it, but I'm a program manager. So that's probably like 5 to 8 of our core members do that. And then the average member probably spends like 10 hours. So we're a little more intensive a club. Yeah, so specifically about the endurance car, the kind of goal of that project, and that's the project that I'm heading up under the team, is to have kind of a 2-seater sports car that breaks a record. It wasn't just to break the record, but it's a car that you'd actually want to drive. A lot of people break these records with like aerodynamic blobs, but we wanted to have something that was like a tangible car. We have about 30 people on the project. Really, really fluid, close-knit team. We're still meeting now through all this and doing a lot of design work, getting ready for the next year. Yeah, we had our manufacturing cut short. If you look in the top left, that was a project that a lot of us worked on. A lot of fun welding and manufacturing there. Went into it, we were pretty much ready.
I'm still on a webinar, but if you guys are planning on about to hop in. Is it the same app?
Hello? All right, I'm gonna
Can't
continue.
hear. Oh.
Yeah, so pretty much where we are right now is we're getting ready to manufacture a lot of different things. We got cut short by coronavirus stuff coming around, but when we're back on campus, we're gonna need a lot of hands to help manufacture. So hope you guys can join us in that. And then Kristen wants to talk a little bit about solar car.
Sure, as Joey said, my name's Kristen. I'm a third-year mechanical engineering student, so Prove Lab does have students from the non-aerospace department. The solar car is Prove Lab's first project, which started about 4 years ago with the inception of the club. Our goal is to break the world land speed record for a solar-powered vehicle, which is currently set at 56 miles per hour, and we're aiming to go with 65 miles per hour As you can see, the aerodynamics were very important to the design. At this stage, we've completed most of the design and the construction, which included a lot of composite manufacturing. The entire car and its structural components are carbon fiber. And at this stage, we are doing testing for the project. We were hoping to achieve the record this summer. Obviously, we got cut short by some of the circumstances currently, so our project will be extending into next year, and there will be more opportunities to get involved with the testing and the record run of the solar car.
Do you guys have any questions for us about Proof?
I have a question about the solar car, Kristen. So can you kind of put it in context how much power is being generated by the solar panels and to get the vehicle up to hopefully 65 miles an hour?
Yeah, sure. As you can see from the picture of the car, it looks pretty unusual. It's very long and flat. It's about almost 20 feet long and 8 feet wide. We have 600 solar panels on it, and that generates during the summer at peak sunlight about 2 kilowatts of power, which is approximately as much as a toaster or a hairdryer. And so that is what is propelling the car to 65 miles per hour.
Wow. And a question came in that is, how is the club funded? So where do you guys get materials and funding for this?
Yeah, so it's kind of all over the place. So we get it through, so first off, the club is an IRA, which is just kind of a class of organization on campus. So we get funding through there. The projects are really expensive, or I guess fairly expensive. They're 6-figure projects. So we need to get more than just the IRA provides. We do that through things like on-campus grants. CP Connect is a big one. We've gotten like 10,000 through them. A lot of it is just like reaching out to companies to sponsor us. We had an industrial engineer who joined the team last quarter, and then like not even a week or two after he joined, he called around and got, I think it was like over $1,000 worth of wheels and just donated, because we want to get a specific type of wheel because you want to have I think it's a thin width on the wheel but a big diameter to get the best rolling resistance. So just grants, working with sponsors. Something that the solar car did really well was a crowdfunding event. They raised an insane amount of money through crowdfunding. And you just pretty much scrap from all over the place to find the money. It's pretty fun, like getting on the phone, telling people about the project. And then people are really willing to donate for something like this. Oh yeah, and the aerospace department was like really big with the solar car too, and getting funding there. Yeah, that's about it.
All right. Any other questions for Proof? All right. Well then, thanks y'all. And just to give a broader context to the answer about club funding. So the university has some mechanisms to fund club activities, or what we call IRAs, instructionally related activities. And so depending on a kind of complicated formula, the university allocates money to each of these activities every year. So that's only a small portion of most of these clubs' budgets. So some of the other funding does come from sponsorships, from donated materials, from other activities that those clubs actually participate in, and as well as some funding from the department as well. All right, so next up is CPSS, and that's going to be Lauren and Colton. Take it away.
Hi, everyone. I'm Colton Hook. I'm the president of Cal Poly Space Systems.
Hi, I'm Lauren. I'm the vice president of CPSS.
Sorry. Go ahead, Lauren.
So we're the rocketry team on campus, like Dr. Marshall introduced us. We're completely student run, like most of the other clubs on campus. but the main thing we do is design, test, build, and launch our own rockets. We have two main projects that we work on. Our main one is a hybrid motor rocket, and one of our side ones is a solid motor rocket that we mainly use for learning purposes and getting more people involved and learning more about the club. Colton, if you want to go into competitions.
Yeah, so our main goal as a club is to enter the Intercollegiate Rocket Engineering Competition, otherwise known as IREC. That's held in mid to late June every year out in the desert in New Mexico. That also consists of a lot of other engineering related activities. There's presentations, there's poster sessions, there's networking events. So our goal is to have the hybrid rocket ready to go and flying in that competition at the end of next school year. We also use a facility called FAR, which is Friends of Amateur Rocketry. That's out in the Mojave Desert, about 4 hours from campus. So that's a lot more accessible for us. They hold a competition that's a bit less formal, but is structured very similarly in late May every year, called FAR 1030. Lots of competitions, both IREC and FAR are structured in 10,000 and 30,000 foot class competitions. And so the solid project is designed to be a 10,000 foot rocket, and the hybrid rocket is designed to be a 30,000 foot. So those are the target altitudes, and those competitions are mainly structured. The points that come from flight are based on how close you get to that altitude, as well as whether or not you recover your rocket, which is very important given the safety concerns of a rocket coming back, but also the cost of recovering it. So some other things I wanted to add just about my experience with the club is I've learned a lot from it and been exposed to a lot of information a lot earlier in my college career than I otherwise would have. And while classes tend to be the best way to learn about like the specifics of things and how to do the calculations and how to figure things out, there is a ton you can learn just intuitively by being exposed to things and getting your hands on things. That's been invaluable. Been able to learn how to manufacture things, use machines I really would have no reason or resources to use otherwise. Get in the lab, do testing. One of the labs that was mentioned earlier is the Propulsion Laboratory, and we're very lucky that we have that on campus. It actually allows us to test fire our hybrid engine on campus, which a lot of teams in California actually travel to FAR in order to do their testing, but we're lucky that we can actually do that on campus. Yeah, and to kind of touch on some of those questions, club's open to everyone. We have people from mainly Aero, but across quite a few other engineering majors as well. All skill levels, all knowledge levels. Really, there's no one who can't contribute to a club. I think most clubs would agree that that's true, that being there, being present makes you a much better, like you can contribute no matter what. And time commitments, I mean, that really, I think with anything in life, and especially in college, you'll find the amount of time you put in is directly related to what you can get out of the experience.
Yes. Also, I did not put our website or email on our slide, my bad. So I put it in the chat if anyone has any extra questions to ask us or wants to check out more about our club. You can visit our website or email us with any more questions you might have later. One question in the chat is asking if we're considering designing and building a liquid rocket in the future. It is being looked at. Two of our members are actually interning at SpaceX right now, and they have been getting very involved in liquid rocket engines, and they are trying to put forth an effort into moving the club into that in the future. But for now, we are still working on our hybrid rocket, and that is our main focus, and possibly in the future, that might change since the competitions that we enter don't specify what kind of motor or engine that you need to use in the rocket. All right. If there are any more questions, you can put in the chat or let us know in email. Yeah, thank you.
Thank you, guys.
Thank you, guys. And all right. Next up, there we go, is CP Intercept, and that's going to be Jonathan. Take it away.
Hello, my name is Jonathan Hood with Cal Poly Interdisciplinary Satellite Engineering Project. We shortened it into CP Intercept, figured that was more of a one-bite word, you know. If you can't read my background, you can contact us with the email on the screen at cpintercept@gmail.com. So basically, our project is entirely focused on how close to actual industry can you get with an enclave campus, right? So we got all these parts from Boeing a long time ago in like early 2000s, right? And ever since then, it's been a slowly expanding project. We started with just grad students, and then they said, okay, we need more people. So they opened it up to like higher level undergrads, and then they started opening up to finally everybody. So we're now open to all graduate and undergraduate students. But the whole point of the project is to get as much industry experience as you possibly can by trying and constructing this satellite as close to industry standards as possible. So we're trying to follow every single step along the way for how it works. And that includes, just this last quarter, we started our whole slew of space environments testing using the Space Environments Lab on campus. One of our members, Andres Mendoza, is running that part of the thing. And it's pretty cool. You get to go into the lab, do outgassing tests, atomic oxygen tests, things like that. But besides all the fun stuff, there's always the fabrication and the integration and things like that. There's also the not so fun side of industry that we still have to do. And that's reaching out to your partners, reaching out to Boeing, making sure that these contacts are kept stable and that we maintain a good relationship with them. It's creating grants to get more money for the satellite. It's creating requests for proposals and requests for quotes to try and get more inventory for the project. Because Boeing gave us almost everything, but not quite, just like they gave us almost all the plans, but not quite all the plans. And another one of those is a big thing that we're going to be getting into over this next year, which is, of course, kind of put on hold for this quarter. There's two major components of the satellite that we do not have any designs for. And so we're about to start the process of just designing that thing from scratch, figuring out the blueprints, creating computer models of the whole thing, putting the assembly together, and that kind of a set. But it's pretty great. I would recommend joining. There's certainly room for openings on this club. You can come in and work on whichever part of the system you want. You can be a systems guy, you can be a fundraising guy, you can be industry contracts. We're trying to set up industry tours more frequently than we have been in the past. So we're trying to get out at least one a year, going to places like SpaceX, Vandenberg. We're also in the process of contacting the California Academy of Sciences. They are currently displaying, I think, several different space-related things, and we're trying to see if they're interested in displaying our satellite, which would be kind of cool. Yeah, bit of a name boost in there. I also, incidentally, am a huge fan of Star Trek. Just going to throw that out there. Why I'm wearing this shirt, feel free to, message me on that. But if you got any questions relating to the club in general, just let me know. I can answer whatever you've got. I've been working on this since I was a freshman. I'm currently a junior. I'm the lead on the payload design, the horizontal shelf design. I'm the financial lead, the inventory lead, and the industry contact guy. So lots of roles. There is not generally a student fee for clubs unless the club specifically requests it, to answer that question in the chat down there. I'm an IRA, an instructional related activity. And because we're an IRA, not a club, it means that you don't actually have to accept everyone who applies. There can be an interview process and there can be applications. Now, the only reason that exists is, for instance, our satellite was given to us by Boeing, and Boeing has a lot of proprietary information and materials. And so we're actually not allowed to let anyone in the club who isn't a US citizen, which is why we have to be an IRA and have a registration process. We're trying to work with Boeing right now, actually, to get that ITAR restriction removed. There doesn't really seem to be a point for it anymore since the satellite is so old. But anyway, that's that. all I've got to say.
All right. Thanks, Jonathan. And one other comment about the fees. The only thing that I know that clubs will sometimes ask their members to pay for would be things like if they're buying. And Joey just chimed in with it, like club shirts, and sometimes for like food for the meetings and stuff like that. So there's I don't know of any club that actually has a required membership dues or fees that go into it. And the other thing about that Jonathan mentioned about the difference between a club and an IRA or IRA, that's a distinction that is for the university, and it just distinguishes between activities that are instructionally related that students are intended to learn something from, and other that's the IRA, and then the clubs are more social organizations or things where there is no primary mission of learning. The Cal Poly Rose Float would be an example of I believe, a club. All right, so the next group is Aquafleet, and Aquafleet is going to be represented by Bennett.
Alrighty. Hey everyone. I'm Bennett. I'm the engineering projects lead with Aquafleet. Aquafleet's a weird word. It's this German combination of a few words, academic flying group. So traditionally in Germany, there are these university clubs that design, build, and fly sailplanes, so aircraft without engines. Our club is slowly working towards that model. We're not quite there yet just because of the issue of having a club that flies. We're an engineering club, and then we also help with flight training for folks who are interested in getting their glider pilot's license. If you look in the upper right corner, you can see kind of in the middle, we have a drag rake in our low-speed wind tunnel. So that was a project that we had funded last year for designing and building and testing a wing drag measuring device that's going to go on the plane in the bottom left corner, Nixus. So that's Dr. Iskold's aircraft that we helped build one of the wing panels for. It's a 93-foot wingspan glider made out of the highest performance carbon composites you can find. We helped do flight testing with it. It's an incredibly awesome project to get involved in. There will be flight testing going on with it once this whole virus thing is over too. We also have access to a soaring simulator. So for folks who are interested in getting their glider pilot's license, we can help with your on-the-ground training so you can practice various glider flying maneuvers and save a huge amount of money when you eventually go out and go flying. We have a good relation with the local soaring club out in Avenel, California, sort of by Harris Ranch in the Central Valley, if you know where that is. The club itself does not have folks who fly, I have to tell you that. But a lot of the folks in the club happen to go flying on the weekends. We've had many folks who also happen to be in the club who have soloed in gliders and who have gotten their license in gliders. And it's also a really great community. So in the upper right-hand or upper left-hand corner was a few years ago, after a cross-country camp that we were attending and helping out with. It was a really fun event for us. And besides for just having our own little community, we also have a lot of great connections with industry. So for example, the test pilot for Nixus, Jim Payne, is an incredibly accomplished test pilot who's worked on a few amazing projects. We have a very good relationship with him and his current project, the Perlin project. And we've met a bunch of really cool folks in aviation throughout our work at various airports and glider ports. And that's really awesome in that respect. I think that's about it. Does anyone have any questions?
Yeah, Ben, and I have a question. So some people have been asking this of other clubs in the past. Freshmen and new students, what kind of things would they be expected to be doing if they joined Aquafleet?
Yeah, so similar to a lot of other clubs, it's what you want to make of it. So we have some folks who join that are interested in the engineering side of projects, and we are happy to take freshmen on those projects. A lot of the stuff for drag rake, here I actually have another drag rake right here, which is kind of fun. But a lot of that project was designing electronics for that project. And none of us in the club have a whole lot of experience with electronics. So it's a learning experience for us all. So we're not particularly interested in people who have experience. If you do have experience, that is great though. But we're more interested in people who have a go-getter attitude, and anyone can join us, of course. And then there's also people who join the club because they're more interested in the flying side of things. They want to attend our ground school sessions that we have with a certified glider pilot and learn about the theory that goes into flying, or fly our sim. So we also have folks who are interested more on the flying side than the engineering side, and then we have folks who do both, like myself and a few other members of the club who are really involved a lot.
All right, thanks, Bennett.
No problem.
And then there was a question about, are there any general aviation related organization clubs on campus? And I don't know of any actual IRA or club. Do you know, Bennett?
Yeah, so not including us, there's also the Mustang Flying Club, and they deal with powered aircraft. So we're unpowered, they do powered aircraft. I'm not sure too much about them though. I don't know a whole lot about them.
Hey, Bennett. Hey, everyone. I'm Kendrick DeLima. I'm an Aero grad student. I'm actually kind of part of Mustang Flying Club. I just completed their ground school in winter quarter, so I just finished that up. Typically, they sometimes have barbecues at the airport, just take people flying. I know they're in talks to try to acquire a plane, maybe to like do flight lessons and stuff. It's a pretty new club. I think it was founded last year by another one of my friends who just graduated last year. So that's definitely an up and coming club, and anybody who comes to Cal Poly, like next year will definitely be, reaping the benefits of, like a well-established club.
I see that there's another question in the chat. Do we have a membership/interview/trial process? No. We are happy to have anyone join. You can be any major, just as long as you're a Cal Poly student and you want to help out with our projects or learn about flying gliders, feel free to join our club. I hope I made clear that we do have a lot of folks in the club who do like to go flying on weekends. We have a great relation with the Central California Soaring Association. And there's a lot of folks who, through that good relation, get their licenses at a college affordable price, which is really awesome.
Yeah, and I think Bennett, you're just trying to kind of distinguish between what is a university sanctioned activity and what is outside of the university sanctioning, process. So they're not authorized by the university to actually do the flying part of things, and so that's why they independently go to do those flying activities.
Yeah, thank you for clarifying that.
Sure, no problem. All right, and then just in case other people wanted to know, the question was about whether CPSS and ABCC and whether they have a membership or trial period or whatever, and both of them said they do not either. So
one more quick thing, I'll just drop our contact information in the chat if you want to get involved with the club or ask us more questions.
Okay. And also, if you miss it, if you go to the department's website, aero.calpoly.edu, there is a club section on there where you can see all the student organizations and their contact info. All right, next up is Cubesat, and Cubesat is Justin and Cole. Go ahead.
Hey, Cole's not here, but thanks, Dr. Marshall, for explaining some aspects of our lab earlier. So my name is Justin, and I'm the lab manager at the Cal Poly Cubesat Lab. The Cal Poly Cubesat Lab is an interdisciplinary lab that designs, manufactures, and operates small satellites. So to date, we've launched over 10 CubeSats, and we're currently working on a few more that are manifested to launch in the next few years. Our lab focuses on Cal Poly's Learn by Doing philosophy, so many students who join get opportunities to design, assemble, and fly flight hardware immediately when they join, which is pretty awesome. We encourage hands-on learning and have many opportunities for technical, educational, professional growth. Our lab partners with external companies and educational institutions to procure projects and payloads to work on. So we have ongoing projects with institutions like JPL, Northrop Grumman, NASA, and Purdue, just to list a few. The image on the right is actually our 7th spacecraft, Dave. Dave is a One-Unit Cubesat, which launched in the fall of 2018 on the final Delta II launch out of Vandenberg, which is just an hour south of campus. And everything that you see there is designed or fabricated by students in our lab, and it's assembled in our clean room in the Advanced Technologies Lab on campus. The lab is also managed by students and is about 90% undergraduate students, which is very unlike any other university CubeSat labs. And since our projects are funded by the NSF or other companies that have real world deadlines, all of our projects also have and carry those strict deadlines, which require us to have an application process to join our lab. But our club is multidisciplinary, and our team is comprised of people from just about every major in the College of Engineering and students from physics, agriculture, math, journalism, and the graphic design departments as well. So our lab is about 100 students strong right now, and we encourage students of all years, especially first years, to apply, because our lab has plenty of projects and we're looking for new students to help out all the time. And it usually takes a year or two just to get familiar with all of the processes within our lab as well. Currently, we're working on research projects such as a microelectric propulsion thruster, thermal systems, X-band communication systems, improving our systems engineering processes, and a few upcoming projects are actually geared towards several lunar exploration technology missions. So yeah, that's a little bit about the Cal Poly Cubesat Lab. You can find more information in our application at our website, which is at the bottom, polysat.org. So yeah.
Justin, I have a question for you.
Yeah.
How big is a 1-unit CubeSat?
So a 1-unit CubeSat is 10 by 10 by 10 centimeters. You can think of it as the size of a square tissue box. But our missions have been 1Us, 2Us, and 3Us, and we're starting to work on our 6U bus right now. So about the size of a briefcase. And
another question, do you all get an opportunity to attend the launches for these?
Yeah, so all of the students generally will have a small launch party by either going to Vandenberg, and the students that are actually on the project and working on the operations side, some get the opportunity to go into the operations room in order to call out that their spacecraft is ready for launch.
All right. And then this is a question from the chat that is generic, but we'll see, Justin, what your answer is. How feasible is it for an aerospace student to be actively involved in more than one of these very cool clubs?
So I would say if you have the time to put in, it's totally possible. I personally am the lab manager of the Cal Poly Cubesat Lab, and I put in about 30 hours a week. And I'm doing some research on the side with some faculty as well. But plenty of our students are members of Cal Poly Cubesat Lab and robotics club. So it's really however much you put in is what you get out of it.
All right, thanks.
Yeah.
And then I would just add to that students, I see students either diving deep into one club, or if they have more than one club that they're interested in, then they may not be as heavily involved in either of the clubs, but they like the different aspects that the different clubs have.
If I could add something onto that too.
Sure, go ahead, Johnny.
A lot of people in their first year, when there's a lot less responsibilities to do classes, will go very surface level on a bunch of different clubs and see what really interests them when the time commitment is a lot smaller, and then dive further into clubs in their second, third, and fourth year.
Yeah, that's a good point. Thanks. All right, so the next group up is the AIAA, and that's going to be Nicole.
Yes, hi, my name's Nicole. I'm the president of our on-campus AIAA chapter, and I also have Austin and Kendrick here with me. They're two other officers who will be talking more in depth about what we do at our meetings. But pretty much AIAA, or the American Institute of Aeronautics and Astronautics, is the largest aerospace single society with nearly 30,000 individual members in 85 countries. Our club holds bi-monthly meetings with professionals from the aerospace industry to help our members learn about the different career paths they can take within the industry. We're also currently working with the Vandenberg Air Force Base AIAA chapter to coordinate some special events for next year. We were going to do some this quarter, but we can't anymore, so they're all going to be pushed to next year, and it's going to be really cool. Austin is one of our corporate liaisons, and he's going to talk more about the speakers that we bring into our meetings.
Yeah, thanks, Nicole. So kind of funny that that question was asked. I actually had the privilege of serving in DBF and in AIAA. And my basic role in AIAA was to get people from industry or aerospace engineering, people from industry to Cal Poly to come give a presentation about the cool things that they've been involved in. So I actually set up and got to listen to presentations from at Cal Poly from some engineers from Scale Composites, talk about their company, retired Vietnam era attack jet pilot. So he flew the Northrop Grumman A6 Intruder in Vietnam, and he had some really cool stories about doing that. And then we didn't have time to actually like the way everything is unfolded, but I was planning on having a Red Bull racing engineer come and give a presentation, and that Red Bull racing engineer, he actually is a professor at Cal Poly. So if you go aeronautics, you'll get to learn a bunch of stuff from him. So yeah, I mean, I think AIAA is a great way to listen to really cool stories about the aerospace industry and get some inspiration.
Does anyone have any questions that they'd like to ask? We don't have any, to answer previous questions, we don't have any charges, and we do have free food at all our meetings. And to talk about being involved in more than one club, AIAA is a great club to be involved with, like even if you're involved in everything else. I'm an officer for ADCC, and I'm part of SFC, which is the Student Fee Committee for the aerospace industry. For the aerospace department, and it's totally manageable if you just like time manage, and it's like really cool stuff that you can get involved in. You just need to be able to like dedicate yourself to more than one thing.
All right, thanks a lot. And sorry. So thanks everyone for sticking it out through all this, and for attending and listening and asking some great questions. And I know we went pretty far past our anticipated ending time, but if anyone has any more questions or anything else, then I think Kendra wanted to show something for a second, and then I will open the floor up for questions. So Kendra, why don't you go ahead?
You see, I just want to let everybody know that we have Aero swag in the department. These are specifically, I don't know if you can see, Aerospace sweatshirts. I have a t-shirt on, polos, stickers, whatnot, that are just specifically to our aerospace department. They don't have them in the Cal Poly bookstore. So once you're on campus in fall, we sell those. You can come by my office, and I can show you what we have if you're interested. They're actually fairly cheap compared to the store. They're like $30 for a sweatshirt. And also, if you follow us on Instagram, Facebook, you can get all the happenings of what's going on with our department. So hope to see you in the fall. Can't do it online. I don't have a way to take the money or get them shipped out. I don't have them here with me at home. Sorry.
Yeah, that's one of the first things that a lot of students will do when they come on campus in the fall, is they'll go visit the department office and purchase their family's aerospace gear. and then send it back to them. So that's a good first. That's a good first task for the student coming on campus. Find the department, purchase all the swag, and learn how to mail it back home.
Yeah, I'll have them on Parents Weekend too, if you come for that. But yeah.
All right. So I'll be here for questions. If not, thank you. Are there any study abroad programs for aerospace engineers? So there are not any that are right now. Well, okay, hold on. Let me step back. So we do have an exchange program set up with a university in Japan for Cubesat, and we've done some exchanges of students for the summer and for 6 months, and they've been doing some work focusing on Cubesat propulsion. So we do have an exchange agreement with the university is called QTech. Through the mechanical engineering department, there is also a university in Munich, that is a technical university in Munich that some aerospace students do go and take classes for a quarter or so at Munich, but we don't have any other ones that are heavily trafficked study abroad programs. A lot of students might do that their first or second year and just do it in a general ed environment. So, all right, so that was a good question. Thanks. All right, well, I will stick around here for a couple more minutes in case some other questions come up. But otherwise, thank you all for attending today. Hopefully, we'll see you in the fall.
Thank you, clubs.
Yeah, and thanks to clubs for putting this all together. Ziao, you had a question?
Yeah, can you hear me?
I can hear you, yeah.
Okay, so this is kind of like, I guess, like a pretty personal question, but I am coming in as an international student and I don't have US citizenship or resident status. So from your experience, do you think that it will impact my opportunities in terms of aerospace engineering, finding internships, getting research opportunities, that kind of stuff like that? Do you think that will make any significant impacts for my education?
So we do have international students that come every year and graduate our program. I think the key is you're going to have to find the right industry to focus your job search and your internship search on, because some of the aerospace industry in the United States does require U.S. citizenship or for you to be what's called a U.S. person, which means you have I think it means you have a green card. But there's a lot of the aerospace companies are really, they also have a commercial side, and they're focused on growing their international exposure, and that's a lot of experience that our students can leverage that are from other countries, as well as all the technical knowledge that they're gaining from our program. So I think the key would be to just make sure that you identify the segments of the industry that are able to hire and work with international students and international companies and organizations.
Thank you.
Sure.
is there just a follow-up question? What kind of resources on at Cal Poly can I use to help me find these specific companies or groups?
So I think once you decide like what areas are of interest to you, like if it's space or aircraft or if it's propulsion or whatever, you can talk with some of the faculty members who specialize in that and they can help guide you. The other places that I would go is I would go to the career services because they have a good understanding of the employers that hire Cal Poly students. And then the third resource that I would point you to would be every quarter they have a career fair where companies come on campus that are looking for interns as well as hiring students once they graduate. And so going to those companies and kind of talking with them about what their what their availabilities are. So that would be my third option, because that one is going to be a lot more just talking to everybody and then finding out what their interests are and whether they're able to bring on international students.
Right. Thank you so much.
Sure. Okay. Let's see here. I thought there was a question that came on. Will Cal Poly accept this year's AP credits? I really don't. I have not heard anything that would indicate that Cal Poly is going to be changing how we accept AP credits this year versus any other year. And I know that we're being very accommodating to the changes in how different educational programs have had to adjust to the coronavirus situation. So I don't anticipate any changes. However, I'm also not the person who makes the final say so on that. I can tell you though that I have heard nothing that says that AP credits are in jeopardy or they're not going to be taken for one reason or another. So that would be something that engineering advising would probably maybe have a bit more information on, as well as talking to the registrar, because the registrar's office is the one who actually makes that determination on AP credits. Okay. And I don't see any other questions on the chat, and don't see any other hands up. So unless there's any final questions, then we will end our session. All right, everyone, have a good weekend, and thanks for sticking around.
Thanks for coming.